Hi everyone. Now we are going to study MTDR 1102 Math for IT. Chapter 1 Matrices Introduction. So in this chapter we are going to study what is a matrix, what are the types of matrix, and what is a transpose of a matrix. So that is what we are going to study in this lecture. Section 1.1, it deals about the definition of a matrix, type of matrix, and transpose of a matrix. Matrices introduction. So what is the definition for a matrix? A matrix is a rectangular array of numbers enclosed in parentheses. So the numbers occurring in a matrix are called the entries. A matrix is nothing but a rectangular arrangement of numbers within the bracket. So each number inside the bracket is called as entries. So let us see an example. A is equal to 213 minus 124. So in this matrix A, we see a bracket, we see a letter capital A, and we see some numbers inside the bracket. So this number 213 is in horizontal, minus 124 is in horizontal, and now 2 minus 1 is vertical, 1 2 is also vertical, 3 4 is also vertical. So the horizontal arrangement is called rows, the vertical arrangement is called as the columns. So now let us see the second example. B is equal to 1 2 3 4. So here also B represents the name of the matrix, and the bracket represents the matrix, and inside the bracket we have numbers. That numbers represents the entries of a matrix. So here we can count the rows, the horizontal arrangement, we have two rows are there, and the vertical arrangement we have two columns are there. So now we are going to see what is the size of a matrix, or we can say the dimension of a matrix, or we can say order of a matrix. So if it is a matrix, it has a size, it has order, it has dimension. So and it is written as number of rows multiplied number of column, that is m cross n, where m represents the number of rows and n represents the number of columns. The first number represents the rows and the second one represents the columns. Now we see the general notation for a matrix. So a matrix A will be like this. As we see in this slide, we have a big bracket. Inside the bracket we don't see numbers. Instead of numbers they give you A11, A12, A13, etc., A1n, A21, A22, A23, etc., A2n, dot dot dot, AM1, AM2, AM3, AMN. So this is a m cross n matrix. So you can see the arrangements, the rows and columns, the horizontal line. The horizontal line we can say the rows, and the vertical lines we can call it as columns. See A11, A12, A13 dot dot dot, A1n represents the first row. A21, A22, A23, A2n represents the second row. AM1, AM2, AM3, AMN represents the mth row. So it has m rows. Now let us see how many columns are there. It is A11, it is vertical arrangement, A11, A21, etc., AM1, A12, A22, etc., AM2, A13, A23, etc. AM3, and A1N, A2N, etc. AMN. So the number of columns is n column. We see the second number in the last column. We see the suffix. So it has n columns. So we can see I have mentioned that rows or in the arrows which represents the columns and which represents the rows. So the order of this matrix A is m cross n. That means m rows are there, n columns are there. So here A denotes a matrix and small a denotes an entry of a matrix. Now let us see the properties of a matrix. The first one, each matrix has denoted by a bold capital letter A or B or C or a dot dot. Any capital letter will represent the matrix. The second one, the size of the matrix or dimension of a matrix, or we can say order of a matrix, defined by the number of columns and number of rows and number of columns. So first we have to write the number of rows multiply with the number of columns. So that will give you the size of the matrix. The third one, the entry whose position in the ith row and the jth column of a matrix A is called the ijth entry of the matrix A, and it is denoted by Aij. So if we want to find the entry Aij, that means we have to see the ith row and the jth column. The intersection of ith row and jth column gives you Aij. So now we are going to see the types of matrices. There are many types of matrices. The first type is a column matrix. What is a column matrix? A matrix with only one column is called as a column matrix. So now let us see example. A, it has 1, 4, 2. It's a matrix. It is inside the bracket. Inside we have numbers. And now when we see the order of the matrix is, it has 3 rows and only one column. So 3 multiply 1 gives you the order of the matrix. Next one, B. B is equal to 1 minus 3. So it has 2 rows and only one column. Since it is having only one column, we call it as a column matrix, a special name. And C, the matrix C is equal to A11, A12, A13, etc. AM1. It is a m cross 1 matrix because we have m rows and one column, and since it is having only one column, that matrix is called as a column matrix. So the next one is a row matrix. What is a row matrix? A matrix with only one row. If it is having only one row, then we say it is a row matrix. So let us see an example. A is a matrix within bracket. We see 1, 1, 6. So when we see the number of rows, it has only one row. And when we see the number of columns, it has 3 columns. So the order of the matrix is 1 cross 3. Since it is having only one row, we call it as a row matrix. It's a special name. So B is equal to 0, 3, 5, 2. So now we see the number of rows. So there is only one row and there are 4 columns. So the order of the matrix is 1 cross 4. Since it is having only one row, it is also called as a row matrix. So now C, we see A11, A12, A13, etc., A1N. So now we see the order of this matrix is 1 cross n. Since it is having one row and we have n columns, so the order is 1 cross n. Since it is having only one row, it is called as a row matrix. So the next one we are going to see is a rectangular matrix. So what is a rectangular matrix? So it contains more than one element and the number of rows is not equal to the number of columns. Suppose if the number of rows and the number of columns are not same, then we say that such type of matrices are called as a rectangular matrix. It has a special name. So now let us see the first example. A is equal to 1 1 3 7 7 minus 7 7 6. Now let us count the rows. When we count the rows, there are 4 rows are there. When we see the columns, that is a vertical one, vertical yes, there are 2 columns. So it is a 4 cross 2 matrix. Since the number of rows is 4 and the number of columns is 2, they are not equal, so it is a rectangular matrix. Also, consider the example B is equal to 1 1 1 0 0, that is the first row, 2 0 3 3 0, it is the second row. It has 2 rows. Now when we see the columns, 1 2 is the first column, 1 0 is the second column, 1 3 is the third column, 0 3 is the fourth column, 0 0 is the fifth column. So 2 cross 5. So now it has 2 rows and 5 columns. It is not equal, the rows and columns are not equal, so we can say that this matrix B is a rectangular matrix. As a general rule, we can say that the number of rows m not equal to number of columns n for a rectangular matrix. So the fourth one is the square matrix. What is a square matrix? So the number of rows is equal to the number of columns. A square matrix A has an order of m, that is m cross m. If the number of rows and the number of columns are same for the matrix, it is called square matrix. See, let us see an example. A is equal to the first row 1 1, the second row 3 0. So it has 2 rows. Next we count the column. It is the first column 1 3, the second column 1 0. It is 2. There are 2 rows and 2 columns. Since the number of rows and number of columns are same, we can call this A is a square matrix. Now let us go for example B. The first row 1 1 1. The second row 9 9 0. The third row 6 6 1. There are 3 rows are there. And when we count the columns, it is 196. Second column 196. The third column 101. So therefore it has 3 rows and 3 columns. The number of rows and number of columns are same. That is, the order is 3 cross 3. So it is also a square matrix. The fifth one is a diagonal matrix. A square matrix where all the elements are 0 except those on the main diagonal. Aij equal to 0 if I not equal to j. So now a diagonal matrix should be a square matrix and all the entries, all the elements inside the bracket should be 0 except those on the diagonal. Diagonal means from the top left corner to the bottom right corner. So that line should be non-zero, all other elements should be 0. So now let us see an example. A is equal to 1 0 0 0 2 0 0 0 1. So now we see the diagonal 1 to 1 is the diagonal, and all the other numbers above the diagonal and below the diagonal is 0. Therefore, it is a diagonal matrix. Also, now we can see the second matrix B. B is equal to 3 0 0 0, first row, 0 3 0 0 0 0 5 0 0 0 0 9. So now it is a square matrix. The order is 4 cross 4. Now we see the diagonal having numbers, and above the diagonal all the numbers are 0, below the diagonal all the numbers are 0. So therefore this is an example for a diagonal matrix. The sixth one is a unit or identity matrix. So unit means one, identity means same. Okay, so now it is represented by I, capital I. A diagonal matrix with ones on the main diagonal is called as unit matrix or identity matrix. So a unit matrix should be a diagonal matrix. If it is a diagonal matrix, it will be a square matrix. And in the diagonal, in the main diagonal, all the numbers should be 1. So then we say it is a unit matrix or identity matrix. Now we see the first example. It is a 4 cross 4 matrix. In the main diagonal we see 1 1 1 1 in the main diagonal. All the numbers above the diagonal is 0. All the numbers below the diagonal is also 0. And we see 1 in the diagonal. So this is an example for unit matrix or identity matrix. The second one, 1 0 0 1. It is a 2 cross 2 matrix, 2 rows and 2 columns. So it is a 2 cross 2 matrix, and in the main diagonal we have 1 1. So therefore this matrix is also called as a unit matrix, because above the diagonal 0, below the diagonal is also 0. And the general format will be like this: A11 0 0 A22. So this A11 and A22 should be 1 for the unit matrix or identity matrix. Seventh one, null or zero matrix. Null matrix or zero matrix. All elements in the matrix are 0. It's a very easy matrix. So all the entries are 0, means it is a 0 matrix. It can be of any order. So it can be 3 cross 1, or it can be 2 cross 2, or it can be 3 cross 3. When you see all the numbers inside the bracket is 0, it is called as a 0 matrix or null matrix. The first example, it is having 3 rows and 1 column. All the numbers are 0. So it is a 0 matrix. Second matrix, it is a 3 cross 3 matrix. All the entries are 0. So therefore it is a 0 matrix. So the general formula is for every entry Aij will be 0 for all I and j. So this is the general rule. The eighth one is a scalar matrix. A diagonal matrix whose main diagonal elements are equal to the same scalar. A scalar is defined as a constant. Scalar means it is a number. Scalar means it's a constant. Constant means it's a number. So a scalar matrix will be a diagonal matrix. In the diagonal, if you see same number, it can be any number, but it should be same number, then we say that it is a scalar matrix. The first example, we see it is a square matrix. In the square matrix, you see the diagonal is C, C, C. C is some constant, it can be any number. So, but it is all of them are C. It is the same number. So it is an example for scalar matrix. The second example, we see a diagonal matrix. We see 1 1 1. all elements above and below the diagonal are 0. Therefore, it is also an example for scalar matrix, and it is also an identity matrix. Now, when we go for the third example, it is a 4 cross 4 matrix, and it has diagonal elements. The diagonal elements are not 0, and all the numbers are same number 6. Above the line we see zeros, below the line, below the diagonal also we see zeros. So this is an example for scalar matrix. Here 6 is a scalar, and in the second matrix 1 is a scalar, and the first matrix C is the scalar. So we can make a general rule: Aij is equal to 0 for all I not equal to j. Aij is equal to C for all I is equal to j. The transpose of a matrix. The next definition is the transpose of a matrix. If A is an m cross n matrix, then the transpose of A is the n cross m matrix. That results from interchanging the rows and columns and denoted by A power t. Suppose if you have a matrix and its order is m cross n, then if you want to find the transpose of A, then its order will be n cross m. Just you have to change n in the place of m and m in the place of n. This is how we get the transpose, by interchanging the rows and the columns. So it is denoted by A power t. So t means transpose. So A is the given matrix. So to find the transpose, we have to interchange the rows and the columns. So the dimensions of A power t or A transpose are the reverse of the dimensions of A. Here the dimension means the size of the matrix. So let us see an example. If A is equal to 1, 0, minus 1, 2. So now let us see the order of the matrix A. So the order is, it has 4 rows and 1 column. So the order is 4 cross 1. Then if you find the A transpose, so we have to change the rows as column. So the first number 1 becomes 1. The second number 0 becomes the second column. Third row minus 1 becomes the third column. Fourth row 2 becomes the fourth column 2. So here we get 1, 0, minus 1, 2 for A power transpose. A transpose. So when we see the order of A transpose, it is 1 row 4 column. So when we see the order of A is 4 cross 1, the order of A transpose is 1 cross 4. So this is how the order changes. So here the column matrix changed into a row matrix. So here in these two examples, we again see the how to find the transpose. If B equal to 0, minus 1, 2, 0, 5, 7, 0, 0, 0, then B transpose is equal to, so now we have to find the B transpose. We take the first row 0, minus 1, 2, and we write it as the first column 0, minus 1, 2. We take the second row 0, 5, 7, and we write it as the second column 0, 5, 7. We take the third row 0, 0, 0 as the third column. So it is a 3 cross 3 matrix, and B transpose is also a 3 cross 3 matrix, but the rows has been changed into the columns. If we go for the second example, if A 2 cross 2, if the size of the matrix is 2 cross 3, is 2, 4, 7, 5, 3, 1. So they give you a matrix A is equal to 2, 4, 7, 5, 3, 1. So it has 2 rows and it has 3 columns. So now we are going to find A transpose. So how we find A transpose? take the first row and write it as the first column. 2, 4, 7 becomes the column. The second row 5, 3, 1 becomes the second column 5, 3, 1. So we get a new matrix. This is A transpose. Now when we look at the order of A transpose, it is having 3 rows and 3 multiply 2 columns. So 3 multiply 2 is the order of A transpose. This is how we find the transpose of a matrix.